Today we will be solving systems by substitution. We need another method because graphing isn't always accurate and it doesn't work for very, very, very large numbers. To solve by substitution, get one variable alone and substitute that expression into the other one. This one starts out nice, y equals. So we can just take that and put it in for y. And that becomes x plus 3 equals 2x plus 5. From there, you subtract x from both sides, and that becomes 3 equals x plus 5. And when you subtract 5 from both sides, you have x equals negative 2. So x equals negative 2, and now we take that number, and I'm going to put it in for this x. Negative 2 plus 3 is 1, so y equals 1. And if you want to write that as an ordered pair, you can. Number 2, we have an x equals, so we take that and put it in place of x. So that becomes 4 times y minus 1 plus y equals 6. So 4y minus 4 plus y equals 6. 4y plus y is 5y minus 4 equals 6. From there you add 4 to both sides, and that becomes 5y equals 10. And when you divide both sides by 5, y equals 2. Taking that number, substituting it in here, 2 minus 1 is 1. So x equals 1 and y equals 2. And you can either list it like that, x equals 1, y equals 2, or as an ordered pair. Number 3, this equals y, so we're going to take that and put it in place of y. 2x minus 2x plus 5 equals 1. 2x and negative 2x cancel, and that becomes 5 equals 1. It's not true. It will never be true, so that is no solution. There's no number that will make that true. Number 4, I'm going to take this and put it in place of x. 2y minus 4 plus 8y equals 16. 2y plus 8y is 10y minus 4 equals 16. From there you add 4 to both sides, and that becomes 10y equals 20. And when you divide both sides by 10, y equals 2. 2 times 2 is 4, minus 4 is 0. So y equals 2, x equals 0. And again, you can write it as the ordered pair if you want. Number 5, we're going to take that and put it in place of x. So 2 times negative 2y plus 3 plus 4y equals 7. When you distribute here, that becomes negative 4y plus 6 plus 4y equals 7. Positive 4y and negative 4y cancel, and you have 6 equals 7, and that means there are no solutions. Number 6, we don't have any nice x equals or y equals. So what I'm going to do is add 2x to both of these. And then that becomes y equals 2x plus 8. And now I can take that and put that in place of the y. So 3x plus 2 times 2x plus 8 equals 9. That becomes 3x plus 4x plus 16 equals 9. 3x plus 4x is 7x plus 16 equals 9. And when you subtract 16 from both sides, 7x equals negative 7, x equals negative 1. And if x equals negative 1, I'm going to put that right here. 2 times negative 1 is negative 2, plus 8 is 6. So x equals negative 1, y equals 6. Number 7, we have an x equals, so that's going to go in here. Negative 2 times 8y plus 17 plus 16y equals negative 34. When you distribute, negative 16y minus 34 plus 16y equals negative 34. Positive 16y and negative 16y cancel, and you end up with negative 34 equals negative 34, which is a true statement. It will always be true. That means those two are the same line, and there are infinite solutions. We're going to skip 8 and 9 and go on to number 7. Looks like we have a problem with our numbering here. One high-speed internet has a $50 setup fee and it costs $30 a month. So 50 plus 30x. The second provider has no setup fee, but it costs $40 a month. And we want to know when those two things are equal.